Hello everyone. Today we are going to look into this LeetCode problem called set matrix 0. So let us look at the problem statement. It says given an m cross n integer matrix, if an element is 0, set its entire row and column to zeros. Simple. And return the matrix. And you must do it in place, which means you cannot use any other data structure apart from the matrix that is given to you. So like you cannot create any other matrix or any other arrays for that matter. So let us look at the example. So here you can see the first example. Here you see there's a 0 at the middle. So what is the expectation? You have to set this entire row to zeros and entire column to zeros. So you can see in the output this entire row is 0 and this entire column is also 0. Similarly, you can see the second example. Here you see a 0, so they set the entire column to 0 here and entire row to 0 as well. Same is done for this 0 as well. They set the entire column to 0 and entire row to 0 as well. Now, before we proceed to the solution, I want you to have a look at this. So they are saying that a straightforward solution using OMN space is probably a bad idea. So here they are talking about the space complexity, and OMN means equal to the size of the given matrix. So what they are suggesting is do not create another matrix to uh, to solve this problem. So basically, they are hinting towards in place only. And if you look at the second follow-up, they are saying that an improvement to this OMN is an OM plus N space. We are gonna have a look how we can solve this problem with OM plus N space complexity. But again, this is not the best solution. So what could be the best solution is what they are asking. So we're gonna look at what could be the best solution. So let us move into the solution. So I have taken an example matrix and I'm gonna walk through this matrix to explain you the algorithm. So first, let's talk about the brute force approach that comes to mind. So what is the approach that comes to mind initially is you iterate over the entire matrix, and wherever you find a 0, like here you find a 0, then you can set the entire row to 0 and entire column to 0 as well. And once done, then again you can keep iterating over the matrix and do the same for any other 0 that you encounter in the process. Which means if I show you a walkthrough here, first you start iterating from this position, this one, then you encounter a 0 here. So what you will do is you will set the entire row to 0. So let's call it 0, 0, 0, and also you set the entire column to 0 as well. And you can do the same to all the elements. So there is actually a problem with this solution. What is that problem? I guess you already have guessed by now that this element which was 1 earlier, we now set it to 0. So when we come to this position, we will see, okay, this element is again 0, so we should set everything in this column as 0, which is wrong actually, because this element was initially 1 and we are the ones who set it to 0. So the problem statement says like you have to uh, set the row and columns to zeros corresponding to those elements which were initially 0, not the ones which you set as 0. So this this particular column shouldn't be set as 0 uh, because this element was initially 1. I mean, based on this element, it shouldn't be set as 0. Based on other elements, it can again be set as 0. But based on this element in the first row, it cannot. This column cannot be set as 0 because initially it was 1. So what is the solution to this? It is a straightforward solution. Instead of setting marking things as 0, we will first mark things as -1, and then after the marking of the entire matrix is done, we are gonna iterate over the matrix again, and wherever we encounter -1, we will set it back to 0. So let me walk through the solution. Okay, we will start iterating from here. We encounter first 0 here. So what we are gonna do, we are gonna set this row as -1. and set this column also as -1. Now we are gonna keep iterating. So here we don't find a 0. Okay, we find a 0 at this place. So we are gonna do the same. Set everything in this column. If it is 1, set it to -1. If it is 0, keep it as it is. And same in the row as well. You see a 1 here, set it as -1. And again, keep on iterating. So next 0 you encounter at this position, call it -1, and again call this also as -1. So, okay, this again, this is the next 0, but everything else is set to -1 already, and this here also everything else is set to -1 already. So now what you're gonna do is iterate over this entire matrix again, and wherever you have -1, you'll set it to 0. So here you see a -1, you are gonna set this to 0. This is already 0, you're gonna set this to 0, set this to 0. This is already 0, set this to 0, 0, set this to 0, set this to 0, set this to 0. In this particular example, our entire array became 0, but that may not be the case always. So, okay, with this way, we are achieving the solution. We are setting everything corresponding to every row and column as 0. But what is the problem? The problem is time complexity. What is the time complexity of this solution? So you have to iterate through entire array. So if we have, since the question says m rows, I'll take m rows. If we have m rows and n columns, you're gonna iterate over each element, and for each element, for example, you are here. Let me pick a different color. For example, you are here. For each element, what will you do? If you encounter a 0, you will set entire column to 0, entire row to 0. So in worst case, uh, what would be the number of steps? So basically, the number of rows plus the number of columns, whichever is larger. So your time complexity becomes m into n into m plus n. This is your time complexity. Now, Uh, can we improve this time complexity? That is the next question. Okay, so to improve over the first method, we have this method 2. I have noted the time complexity of the first method here for reference. Now, in this method, we are gonna take help of two helper arrays. In this array for keeping a track which column can be 0, and we are gonna use this array to keep a track which row is 0. So if you notice, like so this is the first row, right? This is the first row. If any element in this row is 0, then entire row is gonna be 0. So while we iterate, if we find any 0 in the first row, we will mark this as 0. Similarly, we do the same for any other row. So we are gonna know which row will have zeros and which row will have ones. And we are gonna do the same for every column as well. For example, there's a 0. Even if there's 1 0 in any column, entire column would be 0. So we only need to mark one position for every column. So this array is gonna help there. I want to change this example a bit because everything is becoming 0 here. Let me erase this thing and add a 1 here. Yep. Yeah, I think this will work. This no zeros in this row. Okay, fine, fine. Now uh, let's walk through this solution and let's try to understand what we are trying to do here. So let me pick this color. Yeah. So again, we are starting from the first position here. So we see a 1, we have to do nothing here. Unless we encounter a 0, we have to do nothing. Here we encounter our first 0, and this 0 belongs to first first row. So let me give numbers as well here to make it clear. So this particular zero belongs to first row and second column. So which means this zero can set the entire row to zero. So we'll mark this as 1, and this can set, and here this particular uh, in this particular area we have to mark this as 1 because this column, second column, can be 0 because of this 0. Again, we are going to keep iterating until we find the next 0. So we find the next 0 here, and we are going to set the corresponding row and column to 1. And notice here we are only updating two elements here. In the previous case, we were changing the entire row and column. Here we are setting only two values, this one and this one, not setting the entire row and column. So this will reduce the time complexity. Now let us keep iterating. We come to this position, so this means this particular column will be 0, but this row is already set to 1, so I have to do nothing here. Let's keep iterating till we find the next 0. Here this is set as 1, this is set as 1, and the next 0 is here. This is already set as 1. This is already, okay, this was not a right example. Let me change this as also as 1 just to show an example. Right. So here at okay, you don't have any other zeros, so yeah, that's fine. Why I made it 1? Because I wanted some elements in the array to be non-zero. Now you have these two helper arrays generated, row and column. After this operation is done, you have to iterate over the matrix again to get the final result. So how to do that? So let me show what we are gonna do in the next step. So you are gonna iterate over, let's iterate over this column first, column matrix first. So here you see in the first position you see 1, which means the first column of the matrix will be 0. So set everything to 0 here. This is 0, this is 0, this is 0 anyways. And you move to the next position. Here you see 1, so means everything here also will be 0. You see the here we have nothing, so we can move. Here we see again there's a 1, so set everything to 0 here. Now it's time for the rows. After column array is iterated, you go over row array. You see the first element is 1, which means you have to set everything in the first row to 0. Again you see in second element you see there's a 1, so set everything in the second row to 0. Similar, okay, in third there's nothing, so you will keep it as it is. And fourth you see it is 1, so set everything to 0 here. So we have this matrix, only one element is remaining 1, everything else is 0. So this solves our problem. So what is our time complexity here? So initially you have to create the array, I mean iterate over the array anyways. So mn will be there, and then using this mn you can create these two helper arrays. After that what you're gonna do, you're gonna iterate over this column array, so which is you notice here you will add a plus, not an into here, because this matrix operation is done here. In the previous uh, in the previous example, with each iteration only you had to go over entire rows and columns. So you had an into here. Here mn is your entire operation. After mn is done, what you have to do is you have to iterate over this column, and suppose this number of column is n according to the question, so you have to iterate over n elements, and for each element you might have to set entire elements. In the worst case you might have to set the entire rows. I mean if this were also 1, you would have to set everything here as well to 0. So this again will be nm, and after this is done you have to do the same thing for the rows, so this again can be nm. So totally your time complexity here is nm. Here also you can add when, because at the end you have to iterate again to set -1 to 0. So here you can see very much improvement over the time complexity from the previous method. Uh, Again, if you remember the things in the follow-ups, this was the O m plus n space. I mean, the time complexity is OMN, but what is the space complexity here? What is the space complexity here? Here you have two additional arrays. One would be equal to the length of the matrix. Another will be, I mean, one would be the number of rows, one would be the number of columns for creating these two helper arrays. So m plus n is the space complexity. Now, the question asked if we can do any better than this n plus n. So there's another method in which uh, we would again keep a note of 0 columns and 0 rows uh, using the columns and rows of the matrix itself. I mean, here instead of creating this column array, you can use the first row of the matrix, this row, as this helper array. And instead of creating this row array, you can use the first column of the matrix. The problem then arises, what about this intersecting element? Whether it will go for the columns or for the rows. So what we do is we will treat this particular element to be a part of this column array. So basically, basically this first row will this first row will be representing your this column array, and these three rows will be uh, representing three rows in the row array. So basically the first three elements will be corresponding to these three elements. Then one element is remaining only. So for that we can create another variable. Call it call. So for the first row, this variable call will keep a track whether the first, whether the first row is 0 or not, and for everything else you can use this one. Similarly, you can also treat this first element to be a part of this column array. I mean part of this row array, and for the first column you can set this to 0. I mean for first column you can set this to 0 in that case, 0 or 1 based on the condition. So if you are confused a bit, we are going to have a look at the code. Then in that case it will be much more clear. But before moving to the code, I would like to walk you through the solution. Now let's have a look at the third solution. So in here I will keep a variable called call. I will set this initially to 1. So I'm gonna keep this variable. I'm gonna use this variable to keep a track of the first column, and these three variables will be representing the rest of the columns, and these four will be representing 4 rows. Okay, so let's start walking through this example, and I'm gonna explain the algorithm in that way as well. So let me start iterating through it. So here I see 1, so nothing to do. Okay, so I encounter first 0 here. So when I encounter my first 0, what I'll do, in the previous case, what you did, you set the corresponding element in column vector as 0. So here this is only representing the column vector, so this is anyway set to 0. And also you set the corresponding vector in the row element 0. So here the first column is representing the row array, so you are gonna set this to 0. Now you keep iterating until you find another 0. Okay, so here you find a 0. So the corresponding row is anyway set to 0 because this element is only representing the row. Now important thing is you have to set the corresponding column as 0 as well. But here there's no column representation. Column is represented by this call variable. So you're going to set this to 0. Now keep iterating until you find the next 0. So here you find another 0, which means corresponding column you have to set to 0. Corresponding row is anyways 0. So you keep iterating. Okay, you find the next 0 here. Corresponding column set to 0. Corresponding row to 0 as well. Yeah. You find next 0 here. Corresponding row is 0 here as only, and row is the column is also 0 already. So okay, so there's no other one here. Now once this is done, uh, second step is to update the matrix, as in any other algorithms that we have seen till now. We have to update, but here update will be a bit different. Earlier we used to start from this position start. Here in this case we are not going to start from this place, we're going to start from this place. The reason being, if we start from this place, okay, if we start from this place, we are going to set this row and first row and column to zeros as well. I mean, we might set some elements to 0, which is not correct, because this first row and column element is only representing which column and which row should be 0. So you should not alter the first row and the first column until and unless every other rows and columns are updated in the matrix. So you're going to start from this. Again, this particular example is, again, everything will be set to 0. Anyways, I'm going to iterate it anyway. So you start from this position. Let me pick a different color. You start from this position and you see if the corresponding row column is 0 or the corresponding row is 0. If any one of those two is 0, you are going to set it to 0. So here both of them are 0, so you set it to 0. Now you move to this one, this guy, and again you check whether any of those is 0. Here again both are 0, set it to 0. You move to this guy, check. Anyways, um, like for all cases everything is 0, so you're gonna eventually set everything to 0. But what after this? Okay, so now talking about first row and first column. So which should you update first, first row or first column? Uh, you should go with the row because it comes in the iteration. And first row we are not gonna change because this does not depend on anything here. We're gonna change it, of course, but we're gonna change it after our iteration is over based on this 0 here. So after this is done, we're gonna set this to 0. It is 0 anyways. So after all this done, for this particular row, we can check if call variable is set to 0, then we can set this to 0. We can do this at the end of the entire operation. I mean, after checking this entire, after setting the entire matrix, you can run another loop and set this to 0, or you can do together with this only. I mean, with the outer loop, you can check if call is 0 for each iteration, and you can set it to 0. We're gonna look at the code, and maybe at that time it will be much more clear. So yeah, this is the algorithm. So this is constant space. Only you're using one variable, and yeah, time complexity is actually the same. So yeah, let's move over to the code. Let's have a look at the code. So let me first create a column a variable, which again, as we mentioned, will keep a track of whether the first column should be 0 or not. Now let's create the n and m variables according to question. M is okay. N is the length, uh, and n is the breadth. So m is number of rows. So we can do matrix dot length, and n is number of columns. So we're gonna do matrix 0 dot length. Now we're gonna create in place helper arrays. So we're gonna iterate over all the rows. We're gonna iterate over all the rows And for all the rows, if the first element of the row is 0, if the first element of the row is 0, then what we're gonna do is we're gonna set call to 0, because first element of the row is representing the first column, and this is gonna be taken care by the column variable, not the matrix. Check if the first element of every row is 0, and we're gonna set column uh, variable accordingly. After that, after the first element of the row is checked, you're gonna iterate for the rest of the element of the row. So we're gonna start j from 1, and j should be less than n, which is number of columns, and j plus plus. And in this case, we're gonna check if the value at this position, okay, I made another typos. So we're gonna check if the value at this particular position is 0. If it is 0, we are gonna set the corresponding row and corresponding column to 0. So how we're gonna set the corresponding helper column to 0? So the first row in the matrix represents the column, right? So first, how do you how do you write the first row in the in code? So you give first element as 0 and keep the second element as j, and assign this equal to 0. Now you have to do the similar thing for the uh, first column as well, which will be representing the rows, which will be representing the helper row vector. So for each uh, for each row, you set the first element to 0. If you find a value in the matrix which is equal to 0. So yeah, with this we can create our in-place helper arrays. After this part is done, the remaining part is updating the matrix. So how do we update the matrix? Again, as mentioned, you have to iterate from the end, right? You cannot iterate from the beginning because that will create problems of updating the helper rows and arrays as well. So until I is greater than equal to 0, you're gonna keep decreasing I, and then you're gonna iterate for j. J again will be, okay, I keep it as n. Usually I have the habit of using n as the number of rows instead of m, so it is confusing a bit. Anyways, let me call it 10, and okay, yeah. While j is greater than equal to 1. Why 1 here? Because of the same reason, we are not updating the first column here, because that depends on the call variable j minus minus. And again, the same condition if matrix at I 0 is equal to 0, which means if the if the row helper vector is suggesting this row should be 0, or if the corresponding column uh, helper vector is suggesting that this should be 0, I mean if either of these are 0, you set the matrix as 0 at that position. Now, so this is gonna take care of all the rows and columns except for the first row, I mean first column. So for first column, what you're gonna do is you're gonna check if the value of call variable is 0, and if it is 0, you're gonna update matrix at that row and the first column as 0. So this works. and this is what you have to return. Let me run if there's any compilation issues. Oh, okay, they are okay. I made a typo here. Length, my bad. Okay, the initial test case is successful. Let me run it. Yep, it is accepted. So this is the solution. Alright, thanks for watching guys. That was it for this video. If you like, please hit like and subscribe button and also share it among your friends. Thanks for watching. See you another time. Bye.